Welcome back, dear students. Today we are going to see the topic aluminium structures. So, aluminium is a widely used building material now, and it is the next material compared to steel. Nowadays, it's becoming more popular because of its greater strength to weight ratio compared with steel. The pure form aluminium has low tensile stress of only around 89 Newton per mm square. However, if it is treated, then it can be increased to around 550 Newton per mm square. The density of this aluminium is only one-third that of steel, so it is light in weight, and the Young's modulus also is around one-third of that of steel. So the coefficient of thermal expansion is around 2 times that of steel and not having a well-defined yield point. So generally like high strength steel like that we used to take it as 0.2% of proof stress. Then aluminum alloys are found to have very good corrosion resistance, and we are mainly going to concentrate on two aluminum alloys that are widely used for structural applications, the 2014 T6 and 6061 T6. These are specified by ALCO. Now, coming to the chemical composition of these aluminum alloys, we see that copper, silicon, magnesium, manganese and chromium are in varied quantities in both the 2014 as 6061 alloys. So coming to the aluminium alloy 2014 or 2014A, it is a copper based alloy with a very high strength characteristics. So this is mainly used in aerospace structural applications because of its high strength and lightweight, and nowadays it is also used for bridges and other structural applications. The next alloy is aluminium alloy 6061 T6, and it is a medium strength heat treatable alloy. It has very good corrosion resistance and good weldability, and it has medium fatigue strength, but it is not suitable for very complex cross sections. So if we see, this is used for very heavy duty structures like shipbuilding, bridges, military bridges, tube, pylons, towers like this. For various structures, this alloy is being used. Now coming to the physical properties of the aluminium alloys 2014 T6, we see that the mass density is around 2.8 grams per centimeter cube. Unit weight is 27.4 kilonewton per meter cube, and the Young's modulus is very less compared to steel. It is only around 0.73 Newton per mm square, and then we have the shear rigidity modulus and the coefficient of thermal expansion, which is quite high. Similarly, the physical properties of 6061 T6 also are mentioned. So it is lighter little bit, so it is mass density is around 2.71 gram per centimeter cube, and its unit weight is around 26.5 kilonewton per meter cube, and the other properties are almost in the same range. And coming to the mechanical properties like the tensile strength, the compressive strength, shear and bearing, we see that the ultimate tensile strength is around 414 Newton per mm square, and yield strength is 366 Newton per mm square for 2014, and compressive strength is around 379 Newton per mm square, and then we have all the other strength also. So it is comparatively lesser than that of steel, and 6061 still has lesser values. Now coming to the advantages and disadvantages of aluminium. Advantages is first is its high strength to weight ratio. It is very light in weight, corrosion resistance, does not need maintenance, so less maintenance costs like painting, all these things are not required. It is easy to fabricate, and it is also strong in lower temperature. But the disadvantages are the low modulus of elasticity, so which will result in thicker sections, cost and availability. Various sections and all are not available, and then greater care should be given for proportioning the sections, and thermal insulation also is poor, like in roof structures and all. Lot of heat transmission can happen because aluminium is used. Now coming to the stress strain curve of aluminium, the stress strain curve of aluminium does not have a definite yield point. So the yield strength is taken at 0.2% of the strain or at 0.2% proof stress. So it is a continuously rising curve. There is no sharp yield point, and the yield strength is determined arbitrarily by taking 0.2 percentage proof stress, and the yield strength is around 65 to 90% of that of the ultimate tensile strength. The various other permissible stresses of lightweight structural aluminium alloys 2014 T6 and 6061 T6 are given in this table. Now the aluminium structures are subjected to the four type of failures. First one is the buckling and bending. Sometimes some twisting can happen, or there will be combined bending and twisting, and local buckling of the individual elements also can happen. Coming to the applications of aluminium, we have windows, roofs, claddings, all these are light in weight, so aluminium is preferred. Curtain walling and structural glazing, prefabricated buildings are also used, almost similar to the cold form steel. All those applications are here used here also. Large column free space is possible. Such structures are preferred using aluminium. Then long span roof trusses because of the lightweight. Then transmission towers, masts, pylons, like in inaccessible areas and all, where lifting a heavy steel tower or something is very difficult, then aluminium towers are used. And then for bridges also, for shop fittings and partitions, nowadays it's so common, aluminium partitions are used. Even ladders, scaffolding, all these things, aluminium is being widely used. These are the applications of aluminium. Thank you. Watch the video and attend the quiz.